All right, let's talk about something that sounds like it's straight out of science fiction, designing your very own microchips. And what if I told you that you don't need a multi-million-dollar lab? You can actually get started right from your laptop.
So let me ask you a question, straight up. Have you ever wondered if you could design a microchip? I'm not talking about in some fancy, high-tech clean room. I mean right there, on the computer you're probably using right now. Well, the answer is a huge yes, and we're going to dive into how.
You know, for the longest time, chip design has felt like this secret society, right? Hidden behind closed doors, only accessible to top-tier engineers with these incredibly expensive tools. It just feels intimidating, almost untouchable. Well, today, we're kicking that door wide open. So to really get our heads around how this is even possible, we need to talk about one key idea. It's a concept called VLSI. Okay, so VLSI, it stands for Very Large-Scale Integration. Sounds complicated, but here's the deal. It's basically the art and science of cramming a ridiculous number of tiny switches, called transistors, onto one single tiny chip. And these transistors, they are the absolute building blocks of all modern electronics.
And when I say a ridiculous number, I'm not kidding. We're talking billions of them. Billions of transistors on a single chip. That insane density is exactly what makes the devices in our pockets so powerful.
Here's a cool way to think about it. Imagine you're a city planner, but for a microscopic world. Every single transistor is like a building, and the wires connecting them, those are the roads. VLSI design is all about laying out these tiny, hyper-efficient cities that run our entire digital lives. Okay, so planning a microscopic city sounds awesome, but how do you actually do that, especially if you're just starting out? Well, you need the right set of blueprints, the right tool, and that's what we're looking at next.
Meet Microwind. This is a total game changer for beginners. It's this really user-friendly software that takes all that abstract theory about chip design and makes it real, something you can touch and see. You get to actually play with what are called CMOS layouts. Those are the blueprints, and watch how the circuits behave. It's all about learning by doing, not just by reading a textbook.
All right, enough theory. Let's get our hands dirty. We're going to walk through what it's like to build your very first circuit.
Think of this like your first design quest. You'd start with something fundamental, like a CMOS inverter. Then, in the software, you hit Simulate, and you can literally watch the voltage levels change, see the logic flip from one state to another. It's like watching the circuit think in real time. Once you've got that down, you can level up to something like a NAND gate and really start to analyze how these pieces work. So, what the heck is an inverter anyway? It's beautifully simple. All it does is flip the signal. You send in a high signal, a 1, it spits out a low signal, a 0. And if you send in a 0, you get out a 1. That's it. It's basically the opposite day of the electronics world.
And these simple little things, the inverters and the NAND gates, they're like the fundamental Lego bricks of the entire digital universe. Seriously, engineers just take these simple pieces and combine them in really clever ways to build all the complex logic that powers everything from your phone to your computer.
Okay, so playing with digital Legos sounds fun, right? But it's way more than just a cool hobby. This is a seriously valuable skill. Let's talk about why learning this stuff actually matters for your future. When you learn chip layout, you're picking up skills that are in huge demand. You're learning how to take a concept, just an idea, and turn it into a physical blueprint for a chip. You figure out how to make it faster, how to make it use less power. These are the exact things that companies are desperate for. A good layout can be the difference between a phone battery that lasts all day versus one that's dead by noon. And getting your hands on this stuff early on, that is a massive advantage. It's not just about the technical skills either. It builds your confidence. It gets you thinking like an innovator, like someone who solves problems, not just someone who follows a manual. It's a total mindset shift. So you see, this is so much more than just learning a new skill. It's really an invitation to go on an adventure into this incredible, tiny world. The source material for this explainer puts it perfectly. Your journey into the microcosm of technology awaits.
Look, with tools like Microwind, the old barriers are just gone. Chip design is more accessible than it has ever been. The power to literally create and innovate at the very foundation of technology is sitting right there on your laptop. So really, there's only one question left to ask. What will you build first?